Okay, so today we will start with the lens topic.
Well, the lens, like concave, convex.
Yes.
Assalamu alaikum, sir.
Okay.
Walaikum assalam. So basically, if we define lens, so lens is simply an optical instrument used to bend light. So lens is an optical instrument which is used to bend light. And there are two type of lenses that we have to discuss: convex, concave, or you can also name them as converging and diverging lens. So basically, if we consider the first one, so this is the first type of lens, which is known as converging lens, or you can also say it concave or convex. That is convex lens. So we can name them.
And that is convex.
Yes.
I did do this before.
So we call this as converging and convex lens. So
So like
basically,
convex is divergent, right?
convex is converging, concave is diverging. Yes.
Oh, okay.
So basically, if we consider this one as the center of the lens, and if light rays are moving parallel to this central line, which is known as principal axis, this central line is known as principal axis. And let's suppose we consider two lines which are moving parallel to this principal axis. So these two lines are moving, or these two light rays are moving parallel to the principal axis. So these two rays will converge, or they will bend like this, that they will intersect on the other side of the lens like this. So these light ray will meet at a single point, and at that single point, we consider that point as principal focus or a focus point, right? So when parallel light rays pass through the convex lens, so they will meet or intersect both or all parallel rays of light on the other side of the lens. So that point is known as principal focus, or we can just simply name them as a focus. So that's why it is called converging lens, because all light rays merge at a single point.
What is that diagram called? Is it a convex lens or concave?
This is convex.
Okay, thank you.
So basically, when parallel rays of light moves or pass through when parallel rays of light moves through the lens.
I have a question.
Yes.
In glasses, the glasses which people wear,
Hmm.
which convex lens the type?
Basically, in normal daily life, we use both type of lens. We will also discuss that what type of lens fits in which problem. So this topic is also included by name of defect of eye vision. So we will also discuss that what type of lens fits on which type of defect of eye vision. So that topic is also included in our topic of lens.
Okay, sir.
Because first we have to discuss about all the orientation of the light rays coming from the object through the lens. So then we are able to understand that in this problem this lens will be useful for that defect of eye vision.
Okay, sir.
So basically when all light rays merge at a single point, so that type of lens is known as convex lens, and we also call that lens in simple word as converging lens. And the second type of lens is known as concave lens. And for concave lens, you just memorize it by the word cave. Cave is like deep inside. So
Like
if
divulging.
yes, and if you got confused in converging or diverging, so always think about the concave lens. Cave word, cave is like deep inside. So that will easy for you to identify the exact difference between the concave and the convex lens. So this is the shape for diverging lens, or secondly concave. Now you can see this lens is like uh, thick at the edges and thin at the center. So this is called diverging lens. Concave lens. And when light rays move through this diverging lens, so why it is called diverging, we will observe through the ray diagram. So when light rays move through this lens, so these light rays will move in direction like away from each other, like this. And we know that these light rays will never intersect with each other. So that's why in concave lens, virtual image will form, and in convex lens, real image will form. And how to make the image in the concave lens? We have to extend these line in backward direction just to get the image of an object. So basically at this point, we will get our image. And this is again virtual because no light rays intersect each other on the other side, on the focus. So that's why it is called diverging lens, and it also forms virtual image, not real image. We will also write the properties of these type of lenses to differentiate them. So basically in diverging lens, when parallel light rays of light goes through concave lens, all light rays bends away from each other, right? Any confusion?
Yes, sir.
No, sir.
So this is the basic idea and the basic differentiation of the concave and the convex lens. And further, if we talk about the properties of image, that what will be the nature of image from convex lens and what is the nature of image for concave lens. So we also discuss that property.
Sir,
Yes.
like all light rays will bend away if it's a concave lens, right?
Yes.
Or like how? Like, will it form a virtual image or?
Yes, it will form a virtual image. That's why all light rays move in opposite direction or away from each other. So they will not intersect with each other and will not form any image on the screen. Okay.
Okay, sir.
So basically, we are getting a real image in the first case. We are getting real image. And in this, we are getting virtual image. So this is the differentiation between the real and the virtual image. And in our syllabus, there is image formation concept and there is image formation cases at different places when you place object at different point only for the convex lens. There is no case related to the concave lens because we know that concave lens will form virtual image. So that's why there is only a case related to the convex lens is included in our syllabus and there is no other case related to concave lens. So we only need to discuss cases about the converging lens, which is convex lens, right?
Okay. But why not diverging lens? Is it because the image is virtual
Yes,
only?
image is virtual, so that's why
Oh,
in
okay.
each case you need to make virtual image, right? But in convex lens, we are able to form real image plus in few cases we also used to form virtual image from it. So that's why the concept of convex is included in detail in our syllabus. And before that, there are few terms just like in our diagram we already marked them. So let's suppose this is the center and this center point is known as optical center. So we also need to know about these terms because now we call them by their original name like optical center, principal axis, principal focus. So all these concepts are important. And if you just shortly explain them, so the first one is optical center. Because in exams, sometimes they also ask about their definition for 1 mark. So if we talk about the optical center, so this is a geometric center of the lens all light rays passing through the optical center so when light rays passing through the center, so they will pass without any bending, without any deviation. So they will pass undeviated. So this is the first important point related to the optical center. I will also draw the diagram for that because there are three types of rays, or we can say that there are three basic principles on which we have to make all different cases for convex lens. Second, we have principal axis, that's central line. So for principal axis, we consider that one as that is only an imaginary line just for our reference. We know that in lens there is not like any line in the center. So that is just for our reference. So an imaginary line
Sir, I don't understand the definition of optical center. Can you explain it again?
basically diagram on paper we just used to mark that optical center in the middle of the lens, right? But
As in, like, this is the middle of the concave lens, like
it's
that?
like the middle of
Okay.
concave or convex. But when someone design original lens, so they just mark that center or they just design that center geometrically, means it is in the center from all dimensions, right? From all sides if you observe, so that will be the exact center, just like the center of the circle we used to make from that compass. So that is the meaning of geometric center, that if you measure that center, so it will be in the exact center of the lens. So this principal axis is just an imaginary line passing through the optical center, and it is perpendicular to the center. And the third one is principal focus, or in simple words we can also call this point most of the time as focal point. And this focal point can be explained by using definition: point at which all light rays traveling parallel to the principal axis converge at a single point. So that single point is known as principal or focal point. So these are three important terms for our lenses section. And after this, before starting the different cases, if we consider the basic principle of the ray diagram, so always remember, and one more thing, in our exam paper also, we don't need to meet the exact picture of this concave lens or convex lens, right? Because
Wait,
we
what's principal focus again?
principal focus, this point is principal focus actually. When light rays traveling parallel to the lens or the principal axis, so they meet at a single point. So
They
that point is known.
converge at one point.
Yes. So basically in your exam, it is not compulsory that you always make this type of shape for your lenses. If they ask you to draw the complete diagram, most of the time you will also find they just make a straight line, because now we understand the difference. So once you understand the difference, so then it is not compulsory that you always make exact shape for your lens. So 90% in your past paper, you will get a straight line, because that is easy to mark on the paper, and also it is very easy to make the diagram also, because when someone tries to make concave or convex lens, so not all students are able to make exact a curve for convex lens or concave lens. So that's why for simplicity we use a straight line for our lens. So let's suppose if we consider that method of a straight line. So basically this straight line actually represents our convex lens, because now you got the difference of concave and convex. So when we draw a straight line and just write the name of the lens, so you automatically understood that what we are talking about, that either light rays are going to be converge or diverge. And this is our principal axis. So basically this is our principal axis, let's suppose. So when light ray starts to move parallel to the principal axis, so there are three basic principles we are talking about. Principal rays. So always remember there are three types of possibility for ray. The first one is when light ray moves parallel to the principal axis. So this is the first type of ray which is going to be passed through any type of lens. And the second possibility is, so basically this line will pass through the focus point. And secondly, when we talk about the second type of ray, so second type of ray will pass through the center, and from center light ray will move without any deviation. And the third one is when light ray pass through the principal focus. like this. So it will bend and moves. Okay. We have to pass it through the lens. So this light ray will move parallel to the principal axis. So these are three types of rays passing through convex lens, right? Okay, basically we discussed that there are three types of rays that can be traveled through the lens. So there are three different possibilities, and all possibilities are in front of you, that how these rays are moving from one side to another side. And this point, let's suppose, is called the focus point. On the other side, we will also get another focus, because focus will be at the same distance on the both sides. And one more important thing, if you measure this length, if we measure this length from the lens to this focus point, right, or this focal point, so this is known as another term, which is called focal length. So if we measure this length, so the distance between, or the length between, so the distance between the lens and the focal point is called focal length. So basically, this is focal length. So this is another term. So now we have total four terms related to the lenses. Okay. Any confusion?
No, sir.
Okay. So basically, discuss about types of rays, or three basic principle of. So the first one is
Sir, could you explain that focal length again? I didn't understand that.
the principle of rays, or focal length. Focal length.
Focal length.
Okay. So basically, uh, when you mark the principal focus, or the focal point of the lens, right? This purple line actually shows you the principal focus, right? So when you measure a straight path from the lens, this is our lens in center. So distance from the lens to this principal focus, or this focal point, because principal focus, focal point is the same thing. So the distance from lens to this point is known as focal length, right? This is straight measurement. Okay.
Okay, sir, understood. Thank you.
And now if we continue the principle of rays, so the first principle is related to, so when light ray parallel to the lens, so after bending through lens, it will pass through focal point. So all Remember, whenever there is a parallel line passes through the lens, so it will always move through the principal focus. And second point is, when light ray pass through the center or pass through the optical center, will move without any deviation. So that is the second ray which we mark in the diagram. And the third possibility is, when light ray travels through the focal point
Question, sir.
yes,
What does deviation mean?
a bending. Just like in the deviation, in the ripple tank, we discussed that the waves will deviate in different angle or in different direction. So it means no deviation means that there will be no change in direction of the ray,
Like,
right?
oh, okay, sir. Thank you.
Parallel to the principal axis. So these are three basic principles that we mark in the diagram and that we also discuss with description. So always remember these points whenever you are going to solve any type of case related to the convex lens, right? So let's suppose if we consider the cases of the convex lens. So let's suppose if we consider the first case, case number one is when object is at infinity. So in case one, if we consider object at infinity, right? So basically infinity means, let's suppose if you are using a glasses of your uh, the normal glasses that we used to wear on our eyes. So basically if we consider the size of that lens of the glasses, so basically according to that lens, if you place object a little far away from that, so that point is known as infinity, right? When something is out of your range, so that is known as infinity, right? Let's suppose if someone asks you to measure the distance from earth to the star, so you call that is at infinite distance because you are not able to measure that. So same like if you place object very far away from lens, so that point is known as infinity. Okay, so let's suppose again if we consider a straight line for our lens, so we consider a straight line. But always remember, we are talking about convex lens only. There is no concave lens case. So this is our convex lens. And for convex lens, we have to make principal axis. So this is our principal axis, and this is the center point, optical center. Okay, now one more important thing, that now we have to draw the focus on both sides at equal distance. That's why I use this graph paper, so it will be easy for us to measure the distance, right? And how to measure that? First of all, if we consider two light rays coming from the object at infinity. So when object is at infinity, so we consider two parallel light rays coming from a random angle, right? And how we consider that? Let's suppose if we mark focal point like 1, 2, 3, 4. If we count four boxes, so after four boxes we have principal focus, and 1, 2, 3, 4 from the left also, right? So that's why we use this graph paper or this grid, because it will be easy for us to mark the distance at equal point without any confusion. And if you further count four boxes, 1, 2, 3, 4, so this will be twice of focal length. 1, 2, 3, 4, twice of focal length, right? Any confusion?
Uh, just a little bit.
Basically this principal focus is up to you, right? Basically in exam, most of the time they always mark principal focus, or they just mark the diagram, and they ask you to complete the diagram, or sometimes they ask you to mark the principal focus. So basically by the principle of rays we are able to understand that at what point we will get the principal focus. So basically those points which you are going to mark on right hand side, so same points we have to mark on the left hand side, because this time we are talking about lenses, and lenses are transparent. So we can use both side of the lens, just like the mirror. In mirror we use only one side, so in this case we have transparent sides, so we can use both sides. So that's why we are marking same points on the both sides. Okay. So this is the concept of the lenses. And now if we consider two light rays, the first one is passing through the principal focus. So let's suppose one light ray is moving through the principal focus like this. So after passing through principal focus, in which direction this light ray will move? According to the principle, when light ray pass through the principal focus, or it travels through principal focus, so after passing through it, in which direction light ray will deviate? All principle of rays are written on the same page. So when light ray travels through the focal point, the third point, so when light ray travels through the focal point, it will pass parallel to the principal axis. So it means that we have to make a parallel line after passing through convex lens like this. Okay, clear? Any confusion? Okay, so any confusion in the first ray diagram coming from the infinity? When it comes
Uh,
from the principal focus, so use the third point of the principal of ray, it will move parallel to the principal axis. And secondly, if we consider one more ray, so the second type of ray is coming parallel to the first one, but that will pass through the center. So when it will pass through the center, so you can see they will intersect each other. So this is ray number 2. And we are using the second point of the principle when light ray pass through the center. So it will move without any deviation. And how to identify the image? To identify the image, we have to consider this intersection point. And at this point, we are getting our real image. And in exam, they will ask about the nature of image. So you have to define this image also. What are the properties of this image? Basically, they will ask about nature of image. So for the nature of image, we have to discuss all the properties related to the image. So what do you think that image is real or virtual? The first point.
Which one?
We are getting image over here with this green point. So this image is real or virtual?
Good question.
Real. So basically, always remember whenever you get image on the screen, by the term screen, I mean that rays are coming from one side. So definitely screen will be on the other side, just like when you place projector. So screen will be on the other side. Okay. So if you are getting image on the screen, so it means on the other side, you are getting image on the screen. So that image is real image. And I got some properties in the chat: real, inverted, and diminished. So the first one is we are getting real image because light ray is converging on the other side. If you compare it with the diverging lens like this, if light rays are moving away, so in that scenario, you observe that image is formed on the same side. So that is diverging and that is virtual image. So this image is real image. And the second point you mentioned, inverted, so that is also right. And the concept of inverted means you observe ray 2 is coming from the top side, but now it is moving in downward direction. And ray 1 is coming from downside and it is going towards parallel, so it will be on the top side. You can easily identify that this point is on the top and this is on the bottom. So basically your upside will be down. So this is inverted. And by using this length of green line, so by using the height of this green line, you can identify the exact size of the image. So image or the light rays is coming from infinity and you are getting a small size image that is diminished. And basically we use this concepts in telescope. So this concept is especially for the telescopes, or this type of lenses are going to be used in telescope. And the concept of real image is very simple. The concept of real images when image is obtained on the screen. So any confusion in the first case? Or any confusion in convex lens or concave lens? Any confusion?
How can we tell if the image is real and not virtual?
Basically, we started the rays from one side of the lens, like left hand side. Okay. So if you are getting image on the other side, it means on right hand side. So simply that image is real. And if your light rays are coming from left and you are getting image on the left side, it means on the same side. So it means that your image is virtual, right? So very simple concept. And this diagram is for your comparison, that in a converging lens you observe light rays are coming from left and it will focus on right. But in diverging lens, light rays are coming from left and image will also form on the same side. So that is known as virtual image, right? Just like when you place projector in the class, so projector is on one side and the screen on the other side. So when you got picture on the screen, so that is real image. But let's suppose if projector is placed on one side and image is also formed on the same side, so that is virtual image, right? So this is the difference between real image and the virtual image. And we discussed the first case of converging lens, that is convex lens.